Kia ora everyone, and thank you all for being here to listen to the first public introduction to our company, Futurity Group, and some context which merely scratches the surface on the circular economy and the amazing opportunity it presents to the people of Tairāwhiti Gisborne. I am Jacob Kohn, Tairāwhiti born and bred and CEO of Futurity.
Hi, I'm Gaetano Didwell, CTO of Futurity and come from Te Poho. Rupert Patterson, our chairman, resides in Queenstown. Futurity is pioneering the circular bioeconomy within New Zealand across 3 different platforms: biotechnology, manufacturing, and product development. We are endeavouring to lead New Zealand towards a circular economy by developing the future of materials using renewable forestry feedstocks. We then use these feedstocks to fabricate chemicals and materials to lead the way in enhanced manufacturing and design to deliver the most sustainable consumer goods in the world. The technology we are developing fractionates wood into its chemical building blocks, and then we reassemble these chemicals into more valuable renewable chemicals and advanced materials, which can then produce anything from bioplastics to fuels. We identify technology which has low impacts during processing, which reduce water and energy use without hampering efficiency in the endeavour of increasing the value of logs. We see this generating more value within Tairāwhiti to boost the region's strong forestry economy. We are leading the responsible development of materials and products designed with the end of life in mind. For example, what will happen to that material before use, during use, and post-use? How will it be kept out of the environment or landfill? And what are the consequences if it does enter that environment? To do so, we invest in revolutionary research and are developing worldwide partnerships to progress technology to improve the systems which have failed us today, to show that what can be done should be done. These new methods keep carbon out of the atmosphere, keeps waste out of the ocean, and allows us to recapture the value embedded in these products to be reutilized and recirculated far more efficiently.
Here we can see a simple representation of a circular economy supply chain, from feedstock supply through to production, use and recirculation, with various transportation and logistics steps in between. A circular economy to us is a series of global and regional partnerships with various stakeholders and communities collaborating throughout the supply chain. A major enabler to realise a circular economy is the development of transparent supply chains and collaborative relationships which allow for increased efficiency. Why? Because the challenge of achieving a more sustainable global and local society is a complex problem out of the reach of any government, company or individual alone, hence the emphasis on collaboration. Tairāwhiti Gisborne is in a strong position to capitalise on this if community, industry and regulators work together. The appeal for Tairāwhiti is to become leaders in forestry-based biotechnology, and we see it as being the best place to start within New Zealand. With this opportunity comes significant job creation, with many high-skilled roles creating a major regional economic boost. A circular economy doesn't exist unless you capture and recirculate products after use and recover the value from these products. We will now run through the different theoretical situations for a water bottle to show the different possible end-of-life scenarios within a circular economy context.
Our first scenario, reuse, is the case when a water bottle is bought and reused time and time again. Reuse involves less steps to continue to keep the product in circulation, so is the best option for closing the loop, but this is not always possible. This involves low cost, as reusing is free, low amounts of time due to the item already being fit for purpose, and high value retention as the item continues to perform as intended.
Next we have composting. This is a good end of life because if a product is actually compostable, it does not persist for long in the environment under the right conditions. However, composting still releases significant volumes of carbon and methane from the product into the atmosphere, which can then be recaptured but over long periods of time through sequestration. Unfortunately, the vast majority of embedded value contained in a product through each stage of the system is lost when composted. Composting costs relatively a low amount, however, it takes a very long time and not much of the value is retained.
Our third scenario, mechanical recycling, involves disposal of the bottle after use at a conventional recycling facility. This has the least steps after reuse and is a great end-of-life option. It keeps a lot of the embedded material value in circulation, but in some cases, due to the properties of the material, every time it is recycled, there are reductions in quality. For example, bottles become clothes, and then these clothes become carpets, as the properties of the material continue to degrade. Ultimately, after each step, the material is closer to the landfill. As well as this, there are cases where virgin material needs to be added to make the recycled material processable again. Mechanical recycling is relatively low cost and can be conducted reasonably fast and has an average amount of value retention during the process.
Finally, we have chemical recycling. Although taking more steps than reuse or mechanical recycling, this process changes the material into its original form, allowing it to be recycled back into the highest quality applications, for instance bottles to bottles. This keeps the carbon captured in a material form and out of the atmosphere or the environment. In many situations, we believe this is the most promising form of recirculation after reuse. There is a cost factor, but this will come down with time and technological advancements. Relative timeframes for the process is small compared to other end-of-life options, and there is a lot of value retention. Incineration for energy production is also another end-of-life scenario. However, we do not see New Zealand needing energy produced for this in the near future, and the long-term vision of Futurity is to keep carbon in circulation. Incineration does have its place. It is not fair to say that reuse will always be better than composting, mechanical, chemical recycling, or incineration, because end-of-life is unique to its application and will need to be reviewed on a case-by-case basis. These four end-of-life scenarios are all part of the solution, hence the importance of a circular economy approach when thinking about product design.
Moving into a circular economy involves transitioning from old carbon feedstocks to new carbon feedstocks. For instance, in the old system, which stems from the first and second industrial revolutions, oil is typically mined and produced into chemicals through energy-intensive processes. Products are designed without the end of life considered, and this usually means poor recycling rates and accumulation in the environment and global pollution. In the new system, the third industrial revolution, wood is grown, and using natural biology, we can then produce chemicals and materials. These chemicals and materials are then made into products that are designed with the end of life considered. Partnerships and education are developed to improve recycling, collection, composting, and incineration. By implementing the above, we reduce our impact on the environment and reduce the constant input of additional carbon into the system, which is a fundamental aspect of the circular economy.
Our feedstock is wood from plantation forestry, which sequestrates carbon, is renewable, and makes use of non-arable land, versus oil reserves, which is non-renewable, and food, which competes for arable land and should be used for food production. Our ambition will be to strive for efficient transportation, use of biofuel and/or electrified transport, position ourselves relatively close to port, and always look to improve our emissions. Our processing will need to be carbon positive, low toxicity, use only renewable chemicals, and require minimal energy input. There is a strong chance that we will be able to supply renewable energy back into the grid as well as power our own plant. Our manufacturing will be carbon positive and produce only quality products which are reusable and fit for purpose. Our distribution will also require constant emissions reduction, constant efficiency improvements, and use of biofuel or electrified transport. In use, our products will provide consumers and industry with a more sustainable choice. Then we have recirculation and reutilisation, which captures and recirculates products after use and recovers the value from the products. This reduces the need for virgin materials, reduces greenhouse gas emissions and environmental pollution. There will always be leakage out of the loop, which needs to be supplemented by virgin materials that should and need to come from renewable resources such as forestry.
So this leads us to the big picture. We believe forestry has a leadership position to play in the circular economy and can do much better than it does now to create new standards of environmental and social best practice. We would like to see more value extracted from forestry industry in New Zealand by planting permanent native bush corridors in marginal harvest land, allowing for permanent carbon farming, preventing erosion, and providing habitat for wildlife. There is also potential for integrated land use, such as beekeeping and farming kura, within forests. We also see it is crucial that there is development of fair legislation for the introduction of carbon and emissions, including agriculture. We will strive to improve the image of forestry and make it a dynamic and stimulating industry.
In light of significant climatic and societal challenges that we as humans are going to have to face in the coming decades, a circular economy provides us with a promising opportunity to improve and harmonise our relationship with the environment, to provide more assurance that future generations can enjoy what we do today. As you'll be well aware, our impact on the environment is and will continue to cause irreversible damage to those ecosystems. We cannot afford to delay this adoption any further. Thank you, and sorry we couldn't be there to present this to you. We are happy to discuss any points further and look forward to your questions. Any questions, please email info@futurity.co.nz.